So 8.2.2 says draw the graph of f, indicate on your graph the coordinates of the turning point and the intercepts with the axes. So for 8.2.2 we first have to rewrite our equation and try to figure out our intercepts. So our intercepts will occur when y is 0, like that. And the method that we use to find the intercepts is the following. Okay. So the method that we use in order to find our x-intercepts is we first have to guess one of the values of our x-intercept, and then we can find the rest, because if it's a cubic function we can have a total of 3 intercepts. 1, 2, 3. Not to say that there will be 3. You can get instances where you only get 1 intercept, or where you get only 2 intercepts, something like that. 1 and 2. So guessing the first one, it just takes some trial and error. So you can try very small values first. Try -1, then try 1, then try 2, then try -2, then try 3, then going on and on. If you do that, you'll find that 2 is actually a solution. So if 2 is a solution, that means we can do the following, kind of like division, but not really division. So this will help us identify the missing roots, if there are any. So in here we put the coefficients of our cubic function. So we have -1, we have 1 for x squared, we have 1 for x, and then our constant is also 1. Then since 2 is a solution, we start off here. In order for this to work out, we need to start off with 0 and end with 0 as well over here. So actually there's a mistake here. This should be +2, not +1. So that should be 2. Then we can begin. So first thing we do is we add. So 0 plus -1, that gives us -1. Then -1 times 2, that gives us -2. -2 plus 1, that gives us -1 again. -1 times 2 gives us -2. -2 times 1, we get -1. Our -2 plus 1, we get -1. Then -1 times 2, we get -2. Then -2 plus -2 gives us 0. So it's really important that we start and end on a 0. That's how you know what you've done is correct. Then what are these values that we're getting down here? These are now the coefficients of the rest of the roots that we need. So this would be -x squared minus x minus 1 is equal to 0, like that. And then we can multiply through by -1, we'll get x squared plus x plus 1 is equals to 0. Then you think, are there any factors of 1 that I can add to give me 1 and multiply to give me 1 again? And the answer is there are none, which means that there are no solutions for this, meaning we're dealing with a quadratic, not a quadratic, but a cubic function that only has one real root, which would be 2 in that case. So how we would represent this is we'd say from this point, this would be equal to x minus 2 for the real root, and then x squared plus x plus 1 is equal to 0, like that. And again, remember, this has no solution, no roots. So the only x-intercept we have is x is equals to 2. And we have the coordinates of our turning points. So we can easily plot this graph. Let's get some straight lines here. It's not really straight, but I'll try to draw them perpendicular to each other. So for the first turning point, we had somewhere minus 1 over 3 and 1.81. So over there, if we convert it to a fraction, then the other turning point was at 1, so not too far off, and 3, somewhere there. And then we have our x-intercept at 2. And generally, we can see that this is a negative shape or negative cubic function, which means its value is decreasing as we go on in time. So what this will look like is this, although that's not looking too nice, so I'll try redraw it. Something like that would be better. So you have your turning point, you can indicate that that's minus 1 over 3, and that 47 over 20 something, which is 1.81. And then the other turning point was 1 is to 3, then this x-intercept is 2, or we can say 2 is to 0, like that. So that's our sketch, a rough sketch.